How far can ham radio signals reach you? It is a question often asked in various fora by those interested in becoming a ham or amateur radio operator. Becoming an amateur radio operator needs a license in your country, usually given after qualifying in an examination on radio theory and regulations. In India, for a general grade, you have to pass a Morse code test as well. Though many find Morse code a bit difficult to master, I have found it very useful when I used to operate high frequency amateur radio way back in late 1980s. With a limited homebrew, ham terminology for homemade equipment, I could contact the other side of the globe. For me, the other side of the globe is United States of America, which we used to call W land, as the call signs used to start with W. I was using a vacuum tube self-assembled radio with output of about 120 watts fed into a horizontal dipole antenna tied on top of coconut trees, which were in plenty at my parents' home. For receiving, I was using our home Philips radio, which I had modified to cut off the input when the 120 watts output was going to the antenna using a simple relay mechanism. But we had only a short time period in the morning and evening when the signals would reach that far. At other times, I could contact Europe and other parts of Asia. This was on 7 MHz amateur radio band, popularly known as 40 meter band. But 40 meter is not the popular amateur radio band for long distance or DX contacts. It was 20 meter or 14 MHz amateur radio band. I did not have chance to work 20 meter because my home broadcast receiving radio did not cover that band. That was in first innings on ham radio. In between, I had been off ham radio for about a decade and came back with a renewed interest and license this year. This time, my activities started on 2 meter VHF band or 144 MHz band. My range was very limited to just a few kilometers on simplex mode. I could access 2 local VHF repeaters which could take my signals a few hundred kilometers at the best of operating conditions, but usually only about 150 kilometers. That was with my quarter-century-old VHF radio. When I acquired a new radio with VHF and UHF capability, I started experimenting UHF with my local friends. All I could reach is just 1 kilometer on UHF or 436 MHz band. Then came the possibility of satellite operations when a local low Earth orbit LEO satellite repeater contact group was formed. FM satellites are LEO satellites with cross-band repeaters. Easiest one to work is the amateur radio on International Space Station, known in short as ARISS. It is the easiest because it is at an altitude of only about 420 km and has good power output of 5 watts compared to a few hundred milliwatts for other LEO satellites. This increased the range of my dual-bander VHF-UHF radio remarkably, as the satellite would relay my signals to much more distance than the local VHF repeaters. Initially, I could work only stations about 300 to 1000 km. But as I learned the technique of satellite operations better, the range also increased. My personal record on LEO satellites is 1900 kilometers using my VHF-UHF radio. Though it is nothing compared to the previous personal record on HF radio, please note that VHF-UHF bands are usually meant for local line-of-sight communications and not long-distance communications. It is only because of the satellite repeater located much higher than the local VHF repeaters that I could reach 1900 kilometers. But that is not the limit of amateur radio satellite communications. Some were lucky to talk to astronauts on the International Space Station. There are many in my region also who work through the transponder on the Qatar Oscar 100 geostationary amateur radio satellite located at an altitude of 36,000 km. But that needs much more setup with signals being sent up on 2.4 GHz and received on 10 GHz using a satellite dish antenna. The radio needed for that is much more expensive than the VHF radio which I am using. Setting up the antenna and feed lines for QO100 is much more difficult than setting up a LEO satellite radio and antenna, and I have not ventured into it yet. Amateur radio operations have not been limited to the 36,000 km geostationary satellites. There are quite a few advanced operators who bounce their signals off the moon, known as moon bounce or Earth-Moon-Earth or EME operation. That needs much more expensive and powerful setup than for geostationary satellites, just because moon is about 384,000 kilometers away and does not receive and retransmit your signal like the amateur radio satellite. So only a very tiny fraction of your signal is reflected back and reaches the amateur radio operator at the other end. Huge antenna arrays and very sensitive equipment are needed for voice contacts. Digital contacts with a mode known as FT8 needs much lesser power and has been achieved in our region as well with less expensive equipment. Amateur radio operators have also decoded signals of moon landing way back in 1969. Many amateur radio operators, including those in our region, have participated successfully in contacting the Juno spacecraft when it flew near Earth 1 decade back. That was not on VHF or UHF, but on 10 meter or 28 MHz amateur radio band on Morse code. So, as some would say, the range of an amateur radio is really the sky. There are also many who launch pico balloons which circumnavigate the Earth, and CubeSats, which are tiny amateur radio satellites of 10 cm into 10 cm into 10 cm form factor. Many CubeSats are made by school children as their science project.